All right, we are in geometry. Today's date is January 14th. It is a Tuesday. The year is 2020, just like my vision. Why is this happening? Like, I'm trying to write right there and it doesn't work. If I move down and up. It might be because I'm pressing too hard on that part of the pad. I don't know. Yeah, so we're using similar and congruent triangles to solve these problems. These problems are notoriously the hardest thing in this unit, if not the hardest thing in geometry class. They are redonkulous. They're hard. So just be warned, this might be the hardest thing you learn in the entire year, not semester, year of geometry. Now that you guys are thoroughly scared, let's go ahead and get started with this lesson. So, who can read our objective with a quiet raised hand? Who has a card? Julian.
Use properties of similar and congruent triangles to solve the variety of the triangle.
There it is. Thank you. Mumble a little bit towards the end, but I do that too. Yeah, so we're doing puzzles. And the puzzles can look like example 1. They can look like example 2. They can look like example 3. They can look like example 4. I try to put as many types and squeeze them in as possible, but I ran out of room. So there are other types that might show up that aren't on here, and you're going to have to learn how to solve them on your own. So let's do example number 1. And Julian, your card is eventually being passed around. Thank you, thank you. Example 1, we have a diagram below. We have a rectangle. It tells us it's a rectangle. So from the fact that we just know it's a rectangle, we know that these are right angles. We know that these are parallel right there and there. Question, Andres? Oh, you've got it? Yeah, we're trying to find the area of the rectangle, and we only know this length right here and this length right there. That's not enough to tell me the area of the rectangle, especially since I don't even know what's going on in that line segment right there. Andres, talk to us.
I know how to set up the equation.
Oh, you do? Okay, so let's pause for 10 seconds, let everyone think, and then we'll come back to you, Andres. So how are we going to find the area? Well, to find area, we definitely need some length there and some length there. Once we have those two lengths and we just multiply them, we've found the area. But how are we going to find those lengths? This is a hard problem right off the bat. What are we going to do here? So everyone is clear on the goal. We're trying to get the side dimensions of the rectangle, or maybe some other way. And we obviously are going to be using similar triangles, maybe some congruent triangles, but mainly today is the focus on similarity because this unit is similarity. So how are we going to set this problem up? Okay, so you guys have definitely thought for enough time. Andres.
So, you can, for like the length on the bar, the base thing, it could be the 10 right there.
Sorry, this 10 right here?
Yes.
Okay.
And AE 2.
AE's 2? Where'd you get 2 from?
No. Wait, can you do AE over EC?
AE over EC. Okay, so I do this divided by this.
Yeah.
And then what?
AD over DE.
AD over DE. That would work, except we have 2 variables. We don't know that one, we don't know that one. You need to create something that you only have 1 variable. So you're actually really, really close to the mark. You're just off by a little bit. I'm going to help you guys set this one up. So I need to find 2 triangles that I know almost everything about, where I only have 1 unknown. That's kind of the strategy for all of these. Find as much information as you can. Well, I definitely know 2 things about this triangle, DEC. So I'm going to rewrite this triangle, and I'm going to say this is triangle DEC. It's kind of the large triangle right here. So this is going to be triangle DEC. Go ahead and copy it down with me. I know things about DEC. I know that line segment DE is a length of 3. I know line segment EC is a length of 10. I need to somehow find another triangle. It is going to be smaller. Another triangle where I know at least one thing. I know one thing, but not the other, and I'm going to label that X. Because we have 1 unknown variable, we can set up some sort of proportion, assuming that maybe not assuming, but somehow showing that they're similar triangles. And then knowing that they're similar triangles, we can actually solve that problem. But what triangle am I talking about here? What's a triangle that I know at least 1 piece of information about? Does anyone see it? It's kind of hard to see. What's 1 tiny triangle that we have a piece of information about? Andres, don't you have your card in? Thank you.
Yeah.
Sergio and Fernando, are both your hands up, or is it just Sergio? Okay, yeah, Sergio.
This is AED.
Is AED. Yeah, so this is AE is the point right there, the vertice, and then D is right there. And we know for this triangle AED, we have this segment right here. We know that that long leg is 3. So I come down here, AE is 3. We use the same measurement twice, but for 2 different triangles. All right, so I'm going to set up a proportion, but before I do that, I need to somehow convince you guys that these 2 triangles are similar, which allows us, it unlocks the similarity theorems. So, how am I going to do that? Well, I know that these are both 90-degree angles. Why do I know that? Well, I know it's a rectangle. Therefore, this angle, that actually doesn't help us. Actually, they're both right angles. Since this is a right angle and this is a line, this also must be a right angle. So we know that both these 2 angles are right angles. What else do we know? I somehow need to show you that this angle and this angle are congruent, or that this angle and this angle are congruent. And I could show you that. It's going to be a little bit complex. The general idea is that there's 180 degrees in a triangle. So if I subtract 90 from both of them, because I know that 90 is in both of them, I know that these 2 angles here and here must add to 90. I know that these 2 angles here and here must add to 90. Oh man, the proof of this is kind of difficult. And because we already have a long lesson, I'm going to have to gloss over this. I apologize to you guys. If you want to ask me more why they're similar, I can do a proof, but I'm going to have to skip over this. We're going to assume that these are similar now. If I assume that these are similar and I'm trying to solve for an unknown, which unknown am I going to be solving for? Am I going to put the x here? Am I going to put the x on ED, on AD? Where should the x go logically? Which x can we solve? Jose?
DE.
Yeah, DE. Because it matches up, it's a corresponding line segment to something that we have information about to ED over here. And I'm noticing that this big triangle, is this correct? ED is a big triangle, DC, isn't ED, do we mess up on making this triangle? I did. Hold on, let me relabel this because these labels are not correct. D should be this lower line segment, because otherwise this is going to confuse the heck out of us. There we go. A and D got switched around. Yeah, so this AE is really the X that we're looking for. Sorry about that. If you can change that in your notes. Because A is that kind of more, it's the bigger of the angles, and then D should be the smaller angle, this angle right here. All right, so I need someone else to set up a proportion for us. Quiet, raise hand. Who's got this? Fernando, do you have your card still?
Yes.
All right, I'll take your card and you can set up the proportion.
So like 3x, 3 over x
3 over x
equals it's easier, 10 over 3.
10 over 3. Perfect. So we're just saying this over this is equal to this over this, and that looks right so far. I need someone to cross multiply and solve. Kind of a lot of steps to do, but I need one volunteer to do it. Cross multiply and then solve. Someone that has a card, preferably. Didn't you turn in your card, Sergio? Okay, you can do it, but turn in your card this time.
I have my card actually.
Don't throw, don't throw, don't throw. Pass it around.
I actually have my card.
Yeah, amazing shot.
We'll give it to you next.
Is it x, no, 10x?
So 10x, multiplying there, is equal to 9. Keep solving.
So,
Divide by 10, divide by 10, and I get x is equal to 9/10, or what decimal? 0.9. Perfect. So that helps us, because we have just unlocked the fact that this AE is 0.9. This AE right here, let's all label it in our diagram, is now 0.9. All right. So now we have more information. We're still kind of missing some pieces. Oh wait, no, we can solve it right from here. We're basically done. Can we find the area of this large triangle? And I'm expecting you to nod your heads one way or the other. Can I find the area of that triangle? I'm seeing a lot of people nodding their heads. How? Quiet, raise your hand. How do I find the area of this triangle up here? Someone that has their hand, or someone that has their card. You guys all have their hands, luckily. No mobsters have gotten to us.
No mop.
Okay, Gunnar, talk to us. How do I find the area of that triangle? Base times height divided by Yep, so base is, you can choose either one of them to be your base. Okay, and then times,
Times height, which is 3.
okay, so it's 30 so far, and then
Divided by 2.
so the area is,
15.
everyone write it down. The area of this triangle is 15, because it's 3 times 10 divided by 2. Mr. Sindel, how does that help us? Well, if we find the area of this triangle, which we can now find, this is half of the rectangle, because the diagonal always divides half of the rectangle. Then we just multiply whatever area that we have over here by 2 to get this area over here. So now I need to find the area of this smaller triangle, which we can now find. What is 0.9 times 3? And this is gonna, you don't need a calculator, but you can definitely grab one. What is 9 times 3? Then move the decimal place.
Oh.
Fire his hand. Who's got this? I'm gonna call on someone. Cohen.
2.7.
Sorry, Gunnar. 27. Move the decimal place to.
2.7.
There it is. So it's 2.7 here. 2.7. Everyone circle 2.7. I like to circle the numbers that are the areas. That way it's not confusing for the line segments. And Cohen, I'll take your card. All right, so I'm going to add those two together. I get 17.7. I'm going to say, okay, well, if this giant this giant triangle added up to 17.7, this triangle on the bottom right must also be 17.7, because the diagonal of a rectangle always divides it equally in half. And then I add 17.7 with 17.7 in my final answer with a quiet raised hand. What's 17.7 plus 17.7? What is 17.7 plus 17.7? Gunner?
34.4.
Close.
5.
Don't shout it out. Carry the 1, because 7.7 plus 0.7 is 1.4, so you have to carry the 1. So it's not 34.4, it's 30.
35.
There it is, yeah. So everyone write down 35.4 is our final answer, and box it. All right, cool. That was a hard question, or yeah.
What another is there like another line?
Is there another line?
Like what am I?
Oh, like, shouldn't there be another line like right there?
Yeah.
You don't have to have that line, but you can clearly see that this would be the smaller area and this would be the bigger area. All right, let's try another problem. About the same level of difficulty, maybe a little bit easier than example 1. Let's do example 2. All right, so in our diagram, we are given the information that line segment AB, this right here, is parallel to line segment DE. So this very top, the very bottom are parallel to one another, and we're looking to find the entire, or just this line segment AC. I'm just looking for that. That's our goal. Let's go ahead and label that X, since that's the thing that we're trying to find. Let's say that line segment AC is X. How are we going to find X? We're given all of AE, this entire length. We're given AB, we're given DE. How are we going to do this? Well, first of all, I can very quickly show you that these two triangles are similar, because if I have parallel lines, if these two lines right here are parallel, then I have alternate interior angles, so that this angle and this angle are the same. That doesn't really help us that much, but I can also do the fact that, wait, alternate interior means that this angle and this angle are the same. There we go. And that this angle and this angle are the same by vertical angles, and by the angle-angle theorem, these two triangles are therefore similar. So now that we know that they're similar, let's go ahead and apply some rules. Let's go ahead and redraw the two triangles. I have a tiny triangle here, and then I have a larger triangle. That's not the best shaped triangle. Larger triangle. I can do this. There. So this triangle is D, E, C, and the smaller triangle was C, and then A, B. And I had to kind of reverse this a little bit. I had to twist this triangle, this smaller triangle in my head. So yes, this point C is still the point C, but notice that you would think that this would be A because that one's farthest to the left, but no, I'm actually rotating that triangle 180 degrees in my head. All right, so from here, I need someone to label some information for us. Label what we've got. Tell me the small triangle, length BC is blah, length DE of the big triangle is blah. Quiet raised hand. Not enough people. Julian. tell me something. You can give me this length, just call it out. Say line segment blah is blah.
DE is 15.
Yeah, so this DE must also be 15. Thank you, Julian. I'll take your card. Another quiet raised hand. What other information do we have? Monse. Tell me a line segment. What do we know? Yes, this AB is 8. Therefore, this AB is 8. Thank you, Monse. And then the third piece of information is kind of harder to quantify, but we know that if we add this CE and this AC, they both add to 30. So that's going to be hard for us to quantify. So what we can do right here is we can separate this 30 into two pieces. If this length is X, this length must be 30 minus whatever this length is. I'll repeat that again because that's the hardest step of this entire problem. We need to use the fact that we have been given 30. This length CE must be 30 minus whatever this length is. Again, this length CE must be 30 minus whatever this length is, which means this length CE is 30 minus X. So we know that CE is 30 minus X, so this length CE is 30 minus X. All right, we need to put X somewhere. Quiet raised hand. Who can place an X on one of these smaller triangles? More people, more people. Jessica, go. Where does X go? On line segment. Careful, careful. You almost had, just read it off of the diagram up here. X is line segment? AC, yeah. So AC and AC match up, so X goes right there. And that matches, right? So this is great. We have corresponding sides. We've done all of the heavy lifting. Now we just have to do the flow, whatever comes from this. So set up your proportion, cross multiply, solve your proportion. Let's do this. So quiet raised hand, set up a proportion. Jose.
So X over 30 minus X.
X over 30 minus X.
8 over 15.
8 over 15. Perfect. Then I'm going to cross multiply. Another quiet raised hand. Who's going to cross multiply for us? I'm going to cold call if no one participates. Jenny. Cross multiply. I'll help you out. Let's do this one first.
15x.
Perfect. And then is equal to, and then keep your parentheses on this next one. So if I cross multiply this way, 8 is going to be out front. What's inside of your parentheses now?
30 minus x.
Perfect. Thank you, Jenny. You can turn in your card. So Jenny has done the cross multiplication for us. We now need to solve, and then we're done. So who can solve? Quiet raised hand. Andres has been patiently waiting. Thank you, Andres. Go for it.
It's going to be 15x equals, you distribute
You do.
8 times 30 to 40, and then 8 times negative x, which is negative 8x.
Thank you. Keep going.
You divide both sides, but oh wait, no, never mind. You add 8x to 15x.
Add 8x to the both sides. And our new equation is what?
Is 21x.
Careful.
20x, 22x, 23x.
Yeah, 23x is equal to
23x is equal to 240.
240. Perfect. And then it's kind of hard to see. Maybe I should do it on the next line down. 23x is equal to 240. And I suppose I could zoom in here. I don't know why I'm zooming so far out. And then Andre's final step.
23. You divide 23 by both sides, and you get x is equal to 10.4.
Is it exactly 10.4?
It's 10.43.
10.43.
3. Yeah. So wouldn't it just be 10.4 since it's less than 5?
Oh, if it told us around, but if it gave it to us exactly, we'll write it. So what's 240 divided by 23 so everyone else can see? Oh, it actually goes out forever. Yeah, so we could round it wherever we want. Normally in the problem they'll say round to the nearest tenth, which means 1 decimal place, or the 100th, 2 decimal places, 1,000th, 3 decimal places. We'll just leave it as 10.43. I just randomly rounded there. Cool. We found x, 10.43. Box it. Yeah, these puzzles, they're fun, they're hard, they're challenging. We have 2 more. Let's go to the back. Example number 3. If there are questions at any time, just raise your hand. We'll answer them. All right, we need to find the length of AC. We have part of it. We know that AD is 1.5. I need to find the full length. All right, so what should we label as X? What are we really trying to find? I mean, we could label AC as X, but we know part of the information, so maybe we should label something else as X. Quiet raise hand. What should we do for X? Where should we put it? What are we really trying to find? What missing information do we need to get? Sergio? Oh, careful. What are we trying to find, like, in this case? We're trying to find AC, but we have part of the information already.
So it's D.
Yeah, if we just find DC, then we found it, right? So know that when we find X, that's not going to be our final answer. Our final answer is going to be X plus this AD. All right, so, yes, bless you. How are we going to find X now? And take a guess, you're probably going to be using similar triangles, which means we might as well draw a big triangle and a small triangle and then fill things in. Notice that every single one of these triangles in here is a right triangle. Let's zoom in here. Every one of these triangles, the big triangle is a right triangle, the small triangle is a right triangle, and using the fact that this is a line and this is 90 degrees, that's also a 90-degree triangle. So I'm going to have at least 2 triangles, maybe 3 triangles, where one of them is bigger than the other. So let's go ahead and draw pictures. One big triangle, one of them a slightly smaller triangle. But which right triangles should we be using in this case? What information do we really have that we can use here? So this is where you guys are going to kind of pick up the ball now. What triangle should we use? I see 2 hands. I need more hands. 3 hands. I'm waiting for the 4th hand, then I'll call on someone. What just give me one triangle. What triangle do we have at least one piece of information about? I need one more hand before I call on someone. One more hand. One piece of... There's a 4th hand. Gunner, go for it.
Okay. Small triangle.
Okay, the smallest triangle? Smaller. There's the small, medium, and large. Which Goldilocks?
One is the smallest one.
Okay, the smallest one. And what are the dimensions of the smallest one? Let's say that this is, if it's the smallest one, this is going to be A, B, D. Give me the dimensions.
DA is 1.5.
1.5. Okay, keep going.
And the other one, the tall one,
BD.
is 4.5.
4.5. Yeah, line segment BD is 4.5. Okay, we've labeled the smallest triangle. Are we going to use the largest triangle or the medium Goldilocks triangle next? We need at least one piece of information. The other one can be an unknown, right? We're just trying to find things. Jose, talk to me. Oh, DB. So we're using the medium triangle, this one right here?
Yeah.
Okay, yeah, let's use the medium triangle. So let's label this D, B, C. Tell me what you know about them.
So CD is X and EB is 4.5.
4.5. Perfect. All right, I'll wait here to make sure that everyone sees where these triangles came from. This is your time to catch up, to understand. Make sure, Sergio, I can see those ears. We're all good. We're all good. All right. What do I do next? Quiet raise hand. I see 2 people, but they've both participated at least twice, so I'm going to preferably call in another person. Andres has already participated twice. Gunner's already participated twice or more. I'm going to call in someone else. Eder, help us out.
X over 4.5.
X over 4.5. Continue.
4.5 or 1.5.
Beautiful. There it is. Eder's doing medium over small is equal to medium over small. Thank you, Eder. I think I've called on everyone now, right? Cool. Julian, do the next step for us. Here, I'll help you cross multiply. 1.5 and x turns into 1.5x. Do the other side. 18 point what? Close. 18 point something 5. I'll help you here because the calculation, you're supposed to use a calculator for these problems. 4.5 times 4.5. Oh, it's not 18, it's 20.25. All right, thank you. Come back here. 20.25. Thank you, Julian, for doing the cross multiplication. Question, Gunner.
So back in the day when we were in Miss Garcia's class, we used to do cross multiplication, and when we did it like this, she said it was wrong.
Why?
I don't know. She never told us why. She just said it was wrong.
You're wrong.
She said you couldn't do. You said you couldn't do 1.5, or she said you can't do a whole number times x.
Don't know. Maybe there's some memory there, or maybe she was just incorrect. I don't know. But you are definitely allowed to do this. And then from here, I'm going to do what to both sides? Who's got some easy way to get in here? I want to call on more people that don't normally talk. Jessica. 1.5. Someone with a calculator, help Jessica out. What is that? Or maybe, Jessica, you have that? No? Maybe? No? Okay. What is both sides divided by 1.5? On the left-hand side, Jessica, tell us you're going to have what on the left-hand side of the equal sign? After I divide both sides by 1.5, what is the left-hand side now, Jessica? X. Perfect. And someone else, quite raise hand. Who has a calculator? Kind of. Sergio, yeah, what do you got?
It's like 1.26.
1.26. Can you confirm, Andres? 0. What? It should be, I mean, 20 divided by 1 is
Sorry.
close to, I'm going to guess it's somewhere around, I don't know, 14?
13.5.
13.5? Okay. 13.5. All right. Are we done? Did we find X? Didn't we finish the problem?
Yes.
No. What are we trying to find? Read the original problem. We're trying to find the length of AC, and we just found X. I don't care about X. I need to find AC. Question, Andres.
Wait, so why wouldn't you do 4.5 times 2 instead of 4.5 times 4.5?
You could do 4.5 squared, but not 4.5 times 2. Can you stay in your seat, please, Gunner? I'm going to call on someone that's in their seat. Yeah, Fernando.
You do 13.5 plus 1.5.
Oh, yeah, what is that?
I don't know.
13.5. Oh, yeah, 15 plus 1.5 is 15. And there is our final answer. Box it, 15. Thank you, Fernando, for answering and staying in your seat. We are on to example number 4 if there are no questions. This is the time to ask questions on example number 3. How did you know to put X there, Mr. Sindel? Where did this come from? Questions. Get your questions here. Question, Sergio.
How will you find the area?
How would we find the area of this thing? Well, you could use Pythagorean theorem to find the hypotenuse of the medium triangle, which would be this hypotenuse right here. And then you do the Pythagorean theorem again for this smaller triangle to find that diagonal right there. Once we have those lengths, then we can find the area. Yeah, and that might be a question that you'll encounter. What's the area of that shape? My stylus, come back. All right, let's go on to number 4, our final example. Ooh, this guy looks interesting. All right, so we need to find the length of line segment AC. So we already are given AD. What should we label as X? What do we really need to find in this case? Jose? DC, yeah, let's label that X. Because once we find DC, then we'll have all of AC because we already know AD. So again, as a reminder, once we find X, we will not be done because we'll have to add X to 4, and that will give us our length of AC. All right, so I have 2 triangles. I have a big triangle and a small triangle, kind of related to the warm-up unintentionally, but there are definitely 2 triangles in there. Let's go ahead and draw a small triangle and a large triangle. I didn't really prove that these 2 triangles were similar, but I'll definitely show it down here. Ooh, it didn't give us enough information to actually prove that they're similar triangles, but what should have happened is these 2 triangles should have had parallel lines. Back to your peers. All right, so example number 4. We have 2 triangles. We are assuming that they have parallel lines because otherwise you can't prove that they're similar. With parallel lines, you don't have to write this down. Parallel lines means that these angles here and here are the same, and then therefore vertical angles are the same. You can do the same thing over here and here because you have 2 angles that are congruent. Therefore, you can use the angle-angle theorem, and et cetera, et cetera. You have similar triangles. I know that was kind of fast, but again, if you have any outstanding questions, well, how did you really know how to do that? Ask me after class. So I have 2 similar triangles. Let's go ahead and label them with their vertices. I have the smaller triangle as DEC. I have a larger triangle as ABC. And quiet raise hand. What can I fill in here? Actually, this is so fast. I'm just going to do it on my own. I know that AB, this bottom is 9. I know that DE is 5. I know that DC is X, but I'm missing something. I'm missing length AC. And very similar to example number 2, what is AC? Gunner, you've been waiting patiently in your seat, thank you. What is AC?
I have an estimate. It's a guess.
Okay.
I take a guess, and if we get it right, I get $500.
No. Tell me AC. Say again?
Is it 4?
Not quite. That's AD. I need to have this and this. Add them together, Gunner.
Oh, 8.
Hey.
You got this, Gunner. It's still you. What is 4 plus X?
4 plus X is 4X.
Aww.
Is that really the end?
It's 4 minus X.
Yes, sir.
What else? What,
Okay. Well, I'm going to finish this video. You guys are in charge of... All right, I'm back. I'm doing this recording at break. So we know that this length was 4 plus X. That's not the... I kind of want to write it diagonally if possible. 4 plus X. It's really trippy to do that digitally. Because it's just the length of 4 and X, so 4 plus X. So when I set up my proportion, I'm going to do X over 4 plus X. Small over big. X over 4 plus X is equal to small over big. 5 over 9. Cross multiply and solve. So when I cross multiply, 9 times X is 9X. And then cross multiply in the other direction, 5 times the quantity of 4 plus X is equal to 5 times the quantity of 4 plus X. If you ever have things that are being added or subtracted, make sure that they have parentheses whenever they're being cross multiplied. All right, let's solve. So I still have 9X on the left-hand side. On the right-hand side, I need to distribute. 5 times 4 is 20. 5 times X is 5X. So 5 plus, I need to write neater, 5X. If I slowed down, then it would be a little bit better, I feel. Then from here, solve, subtract 5X on both sides, minus 5X on both sides, minus 5X on both sides. And that goes away to 4X, and that's equal to 20 now. Oh, this is going to come out really nice. I'm going to divide both sides by 4, divide by 4, divide by 4, and X is therefore equal to 5. And that's not the answer, so that means that this segment right here is 5. Ooh, what's going on? 5. And I'm asking for AC, so AC is 5 plus 4, and the answer is 9. All right, so there is the end of the notes. Make sure to begin the work on Khan Academy. They will be difficult. I'm expecting to go over this type of question actually for the warm-up tomorrow because there's probably going to be a few outstanding questions. If you guys do have questions at home, please send a screenshot to me. You can use Remind on your computer, or you can take a picture on your phone and remind me that way. Just ask questions. I will write out the whole problem when I get home, and I will send you back a picture on how to solve that problem. Please do ask questions, or be prepared to at least ask questions when you come to class tomorrow. All right, have a good night. I'll see you guys later.